In this video, we're going to continue evaluating limits algebraically. We're going to turn our focus to trigonometric functions. And the trigonometric functions or limits that we're going to be working with are all based on three basic facts. And the first one is that the limit as x approaches 0 of sine x over x is equal to 1. And this is going to be something that we're going to need later on. And it's something that can be demonstrated using the numerical approach, using a graphing calculator and a table of values. It can be proven using a fairly sophisticated geometric proof. But we're just going to assume that it's true. The second one is the limit as x approaches 0 of 1 minus cosine of x over x, and that's equal to 0. And the final one is limit as x approaches 0 of tan x over x is equal to 1. Now these three limits are going to become the building blocks for us to solve these other limits. And we want to look for them as we're doing the other problems. Problem number 65. The limit as x approaches 0 of sine x over 5x. Well, all we need to do with this is to bring out, or to consider this as 1/5 times sine x over x, and the 1/5 as a constant comes out. So we said the limit of a constant times a function is equal to the constant times the limit of the function. So in this case, the constant is 1/5, the function is sine x over x. The limit is as x approaches 0. So since that limit is 1/5 times that will just be 1/5. We'll go on to 67. We have sine x times 1 minus cosine x over x squared, limit as x approaches 0. And so what we're going to do with this one is to split this up into a product of two fractions. First we have sine x over x, and times that by 1 minus cosine x over x. The sine x over x, let me say it this way, the limit of a product is equal to the product of the two limits, so we need to find each limit individually. The limit as x approaches 0 of sine x over x is 1. The limit as x approaches 0 of 1 minus cosine x over x, as seen above, is 0. And so the product of the two is 0. And that's our limit. In problem number 69, we have the limit of sine square of x over x. If we split this up, we get limit as x approaches 0 of sine x over x times sine x. Again, the limit of the product is equal to the product of the individual limits, and that first limit would be 1, whereas the second limit, plugging in x equals 0 into sine of x, gives us 0. And so this result, again, is 0. Problem number 71. We have the limit as h approaches 0 of 1 minus cosine of h, quantity squared, over h. Again, we'll split this up to limit as h approaches 0 of 1 minus cosine x over x times the quantity 1 minus cosine of x. And the first one is one of our important limits, that's 0. And of course, these are only limits. These limits only exist as h approaches 0, or these specific limits only apply when h approaches 0. The second one we can just plug in. When h is 0, cosine of h will be 1. 1 minus 1 is 0. And so this time we get 0 times 0 is 0. In problem 73, we have limit as x approaches pi over 2 of cosine x over cotangent of x. Now we're going to split up the cotangent of x. Actually, 1 over cotangent of x is just tangent of x, and we'll split that up into sine over cosine. So we would have sine x over cosine of x times cosine of x. Cosines cancel, and sine of pi over 2 is 1. And I will go on to problems 75 and 76 in the next video, because those will take a little bit longer to explain.